A quick little review here on functions and their graphs. Specifically, we're going to focus in on the domain, the range, and the difference between a relation and a function, if there is one. Some terminology that you need to know. A relation is a mapping of any type of input value with output values. We'll see mappings, we'll see ordered pairs, we'll see tables, we'll see graphs. Those are all going to be relations because it's a collection of ordered pairs, a collection of inputs and outputs. The domain of these relations is the set of all input values. These will typically be your x values. The range is the set of all output values. These will typically be your y values on your graphs or your ordered pairs, depending on how these are presented to us. A relation is a function if there is only one output for each input. That means each input can have only one output. So all functions are relations. However, all relations are not functions. Going to identify some functions here. Take a look. We'll have -3, 1, and 4 as our input. And then we'll have 3, -2, 1, and 4 as our output. Okay? And our mapping will look like this. -3 will go to 3, 1 to -2, 1 to 1, and 4 to 4. This is called a mapping. We'll determine whether that's a function or not here soon enough. But we're also going to graph these. So this is my input, -3. It's my x, 1, 2, 3, and then up positive, 1, 2, 3. Okay? I have 1 and -2, so I go to the right 1 and down 2. I have 1 and 1. I go to the right 1 and up 1. And finally, my last ordered pair there is 4, 4. So I'll go to the right 4, 2, 3, 4, and then up 4. 1, 2, 3, 4. So we have a mapping, and we have the graph of the mapping. Now the question is this a function or not? Okay, this is a function or not? And the answer is it's not a function. Okay, the input 1 has 2 outputs. So it fails our definition of a function because this input right here, 1, goes to more than one output. We see we have 2 lines coming out of it to different numbers. Another way to look at that is a vertical, what's called a vertical line test, which we'll formalize here shortly. But if I come across here with a vertical line, like if you took your pencil and went across your graph this way, and at any point that vertical line touches 2 points, it fails the vertical line test. So if we look here, we would fail the vertical line test right there because those 2 points right here are on the same vertical line, so this would fail the vertical line test. It's not a function. Let's take a look at one more in this format here. We're going to go -3, 1, 3, 4, and then we'll have 3, 1, and 2 as our output. And it'll look like this. -3 will go to 3, 1 will go to 1, 3 will go to 1, and 4 will go to 2. We'll come over and plot these. 1, 2, 3, 1, 2, 3 for my -3, 3, 1, 1, and then I have 1, 2, 3, and 1, and then I have 1, 2, 3, 4, and 1, 2. So So there's the mapping on our left and the graph of the ordered pairs on the right. If we take a look at this, this is a function. The common thing for people to point out here occurs with 1 and 3, but they go to the same output. That's fine, because 1 only has one output and 3 only has one output. Okay? The other thing we can look at is that vertical line test. Going across here, this direction with the vertical line, we're only going to hit 1 point at a time. We will not hit more than 1 point with the vertical line, so this is a function. Again, 1 has one output, 3 has one output. There's only one line coming out of each of them. Came back to this. The domain would be -3, 1, 3, 4. The range would be 3, 1, and 2. Now, as we look into this example here, and I'm going to sketch a little graph here on the right, probably going to do a couple of these for us. Let's first start with something like this. The domain, if we look, this graph goes on forever and ever. So our domain is all real numbers. Because it's going to go to negative infinity on the x-axis, and it's going to go to positive infinity on the x-axis. The range, however, if we look, the range of the y values, the outputs, our least is 0, and then we go to positive infinity. So this is all positive real numbers. And 0, because 0 is neither positive nor negative. Okay? So that's the domain and the range of that one. Again, the domain, we look at the x's, and the range, we look at the y's. Let's do one more. Let's do something like this. Okay, so we have some goofy looking graph there. Let's take a look at our domain. We go from -1, 2, 3, 4, 5, -5 to 1, 2, 3, 4, 5, 6, 7. So our domain, we can write it as x such that -5 is less than or equal to x is less than or equal to 7. Because we go from -5 to +7, and we have every number in between there. Okay? Our range is y such that y, let's see, we go from -2, and we go up to 1, 2, 3, 4, 5, 6, 7. So we have from -2, less than or equal to y, less than or equal to +7, because we go all the way up there and we include all of those points there. So that's the domain and the range. A couple of restrictions. This is probably the extent to which we'll get to this now. When a lot of you take calculus and pre-calculus and trig in the next year or so, next 2 years, you'll see this in more detail. Again, that vertical line test, a relation is a function if and only if no vertical line intersects the graph of the relation at more than 1 point. So if we look over here, I'm going to draw this. I'm going to draw a circle. Okay? That would fail the vertical line test because I drew a vertical line right here. I have 1 point and I have 2 points. This fails because it crosses that circle at more than 1 point. Parabola, which we'll see towards the end of the year, this passes. It might look a little different. It's not a straight line, but if we took our vertical line straight across, we would only hit 1 point on the curve at a time. Only one at a time.